So in this video, we're going to continue proving, but we're going to prove angle-pair relationships, how two or more angles relate to each other. So you can state how two or more angles relate to each other, what type of angles, complementary, supplementary, linear, pair, vertical, all very important vocab words we learned from the last unit. Then you can set up and solve an algebraic equation that deals with angles, so it's not completely proving, and then you can write a valid proof about an angle relationship. So you should learn so far about all these types of proofs. You have complementary angles, angles that add up to 90, supplementary angles, angles that add up to 180, vertical angles, two angles on the opposite side of intersecting lines. Probably an angle a lot of students don't recognize, but very important. So that would be here and here, or here and here. And then a linear pair, two angles that add up to 180. Notice there's two. These could be more than two, and both are complementary and supplementary angles. So find the measure of the following angles. So again, on the diagram, I like to write what I have. I have HIG is 72 degrees. BIC is 26. AIB is 74. And a lot of times, I like to fill in the diagram before I even look at the question. Is there anything else I know? Well, in here, we have tons of vertical angles. Notice we have intersecting lines, and if I just go bounce over the intersection, so here I have 26, so if I bounce right over, I have 26 degrees here. I have 74 here, I can bounce over to the other side and get 74. 72, I can bounce right to the opposite side and get 72 degrees here. And then the only thing I'm missing is this little angle here. But again, it's important to recognize other types of angles. We don't have any right angles to work with, but I do have a straight line right here, and I have tons of straight lines to help me figure out this angle. So I have all these angles have to add up to 180. So all these add up to 180, so I can go 180 minus all these angle measurements. And really quickly, 80, so those two are 100, 172, so this is only a measly 8 degrees, which I can bounce over to the other side and make this 8 degrees. Now that I have a lot of information filled in my diagram, now let's look at the problem. I'm looking for the measure of FIG, angle FIG, which right here, FIG, I already have labeled, is 26. Then we have AIE. AIE is straight across all of these. If I would add these all together, oh no, it's just a straight line. All straight lines are 180 degrees. Then we have HIE, which is 72 plus 26 plus 74. Or if you brought your A game, you would notice it's just 8 less than 180, so it's 172 degrees. So on this one, I need to find the value of x and y, so I need to figure out how the angles relate. And when we're solving equations, we want to have the same variable. Equations you cannot solve them particularly when you have two different variables, especially if you just have one equation. So here, notice I have 5y and 7y minus 34. So what type of angles are they? Well, they're across the intersection, so they are vertical. And I know all vertical angles are equal to each other, so I can say 5y equals 7y minus 34. Then I can solve. So I get 0 equals 2y minus 34. Add 34 to the other side. Again, there was one quick way. I did it kind of the long way. And then divide by 2. And y equals 17. So now I need to find the value of x. There's kind of a couple ways. I could plug it in for y and get actual angle measurements and figure what this would equal. Or I notice I have another pair of vertical angles and I can set the two equal to each other. And because you guys have all been through algebra, we're going to do 2 steps at once. I don't need You can do step by step. You can do fast track it. So this is 11. 9x minus here is x. So x is 11 and y is 17. Alright, so let's do a proof. So in this proof, angle 1 and angle 2 are supplementary. So I know these two add up to 180 degrees. That is my given. 2 and 3 are also supplementary. So these two add up to 180. I'm going to do a 2-column proof for this one, and I think the next one I'll probably do a paragraph proof. But what I'm trying to prove, so let's put that in blue, what I want is to get these two congruent to each other. Alright, so I'm going to write what I'm given. Angle 1 and angle 2 are supplementary. That is given. You do my 2 columns. You have your statements and reasons. I can also write angle 2 and angle 3 are supplementary. Alright, so now let's kind of go, so what? What does that tell me? Well, since angle 1 and angle 2 are supplementary, that tells me supplementary, if I think of the definition, angle 1, or the measure of angle 1, because I'm talking actually about the measure angle 2 plus the measure angle 2 has to add up to 180 degrees. Why do I know that? Well, I just thought to myself, what is a supplementary angle? Anytime you're asking what is, that's a definition. It wasn't a theorem or a postulate. So that's a definition. I'm just going to abbreviate supplementary angles. 4. I also, from my other given, know that 2, measure of angle 2, plus the measure of angle 3, equals 180 degrees. And that is, by definition, of supplementary angles. Alright, well, because both of these equal 180, anytime something equals the same thing, well, then they are equal to each other. So that same thing keeps showing up over and over again. Two things are equal to the same thing are equal to each other. 3, I need my m's to be proper because we're talking about the measure. There's an equal sign. Congruent, we don't need the m's. Alright, so there, what I did, I really substituted, but I wouldn't mark it wrong if you did the transitive property, because you are using the transitive property. Two things are equal to the same thing are equal to each other. Alright, so now let's look at my goal. I'm trying to get angle 1 is congruent to angle 3, but this is where I'm at. So kind of think to yourself, I need to get rid of angle 2. Well, anytime you have two things on the same side, so think if I had x plus 3 equaled y plus 3, and all I want is x and y. Well, if I subtract by 3 here, they make 0, so they go away. Well, I can subtract here and here, and then they go away. These make 0 and these make 0. Well, why could I do that? Well, that was the subtraction property of equality. Alright, so close. Notice I have equals. I need congruent. Well, equals means congruent. So I can take away my m's and put a congruent sign. Angle 1 is also congruent to angle 3. If they're equal, then they are congruent. And why do I know that? That's definition of congruence. Congruency. Alright, last proof. Alright, so here you're given angle or L and M. The symbol, you might have to think to yourself, oh, making a T. What angle? That's right. You're talking about perpendicular lines. I'm given that L and M are perpendicular to each other. When they're perpendicular, it's a right angle. And then L and N are also perpendicular to each other. I need to prove that this is the same as that. Angle 1 is congruent to angle 2. Alright, we're going to do actually a full proof because I haven't did one of those yet for you guys in a video. So I'm going to say L is perpendicular to M and L is perpendicular to N, and that is given. I know that. Alright, well, so what? Well, if you think, well, if I have perpendicular lines, what did I mark it with? I marked it with right angles. So I then know, since 1 is at L and M and 2 is at L and N, angle 1 and angle 2 are right angles. Why do I know that? Well, definition of perpendicular lines. I used what perpendicular lines were to get here, so that's why I knew it was a definition. Alright, so let's go over here. Well, what does it mean to be right? Well, I'm trying to get these two to be the same. You would think you could just go, well, then 1 and 2 are the same, but it's not. Well, actually, you could say that, because 1 and 2 are both right. Well, there's a theorem. You're actually going to do a little bit on your worksheet. Well, since these two are both right angles, well, then 1 and 2 are congruent. If you think about it, if you think of all the right angles, they have to be the same measure. These are both 90 degrees. Well, since 1 and 2 are right, then 1 and 2 are congruent. You can state that by all right angles are congruent. And you're done. You have 1 and 2 are congruent. Alright, so again, know the different types of angles and their properties. Those 4 are super important, and they're going to show up again and again and again, especially those vertical angles. I cannot tell you how important to know that all vertical angles are congruent. And remember your proof strategies. We're still working through it. It's still going to get easier. I promise. Just keep plugging away and keep working for each other. Remember to do a reflection so you get credit for watching this video.